Hello. Yes. So my name is CA Yogesh and we are doing statistics part 2, chapter number 1, probability standard well. So far this is my fifth lecture for the chapter probability and we have completed a type of event in the last. You can see on the screen there are events and there is a list of type of events we'll be going through very fast. I'll be showing in textbook that we have completed all the topics. Number one was event. So event is the heading I told you. That is a part of a simple space. Then impossible event, the event which never occurs. Certain event which always occur. We have completed each and every single event. Then complementary event is event other than event A. Okay. Then intersection of event, common elements between A and B. Union of event, that is combination of event A and B. And mutually exclusive event, that means if there is no intersection between A and B, then event A and B are known as mutually exclusive event. If A intersection B is null set, then it is known as mutually exclusive. Then difference event, I told you about difference event A minus B, B minus A. Okay, so A minus B is A minus intersection and B minus A is B minus intersection. Same way B minus A, that means B minus A intersection B. Then exhaustive event. Exhaustive event means if A union B is equal to U, if A union B is equal to U, then it is known as exhaustive event. Then mutually exclusive and exhaustive, I told you that if both the thing matches, that means in the same sum, if A intersection B is null set and in same sum, A union B is equal to U, it is known as mutually exclusive and exhaustive event. Yes. An elementary event, that means event of consisting of single element. Let us start with illustration number 6. So there are there are 3 yellow and 2 pink flower in a basket. One flower is randomly selected from the basket. Total there are 5 flowers, 3 yellow, 2 pink. One is selected. Denote the selection of yellow flower as an event A and selection of pink flower as an event B. Find the sets representing the following events and answer the given question. Number 1, sample space U. Number 2, event A, B, A dash, B dash, A intersection B, A union B, and so on. Okay, let's start the sum. We'll be doing one to one. Let me give the heading illustration number 6. So there are 3 yellow and 2 pink flower. One flower is selected. Denote the selection of yellow as event A and selection of pink as event B. Let us start with number 1 question. Sample space. Sample space is what? How many total flowers are there? Sample space means everything, you know. Okay. So total there are 3 yellow and 2 pink flowers. So there are 5 flowers. So we'll name it as Y1, Y2, Y3. We'll name it as Y1, Y2 and Y3. So these are the yellow flowers. And 2 pink are there. So P1 and P2. So there are total 5 flowers. 3 yellow and 2 pink. So sample spaces Y1, Y2, Y3, P1, P2. So this was the first question. Now second question. What is second question? Second question is to find A. Now it is already mentioned that selection of yellow flower is event A. So event A is selection of yellow flowers. Yellow flowers is y1, y2 and y3. Let us give a space so that it doesn't congested. So I have done A also. Let us do with the B. What is B? Selection of pink flower is B. So B is P1, P2. What is fourth question? It is A dash. Now what is A dash? I told you that you have to look into the sample space. What do you have to do? You have to look into the sample space. Event other than A are A dash. Okay, how sir? You have to look into the sample space. See, this is A. If this is A, then this is A dash. Event other than A are A dash. Okay. So simply I can write P1. Okay, simply I can write it as in P1, P2. Okay. Now the fifth one. Fifth is B dash. Now what is B dash? Events other than B. Okay. So if B is P1, P2, then other than B are Y1, Y2 and Y3. Yes, it is Y1, Y2 and Y3. So this is B dash. Then sixth one. A intersection B. Now A intersection B. See, A is Y1, Y2, Y3. B is P1, P2. Or do you think there is any intersection? Do you see any common elements in A and B? No. So intersection is null set. Intersection is null set. There is no intersection between A and B. So seventh question. Seventh is A union B. Now A union B is all the elements of A and all the elements of B. So I'll be writing Y1, Y2, Y3, P1, P2. Okay, it's Y1, Y2, Y3, P1, P2. Eighth one is A intersection B dash. A intersection B dash. Now what is A intersection B dash? We have both A also and B dash also. See, this is your A. So you can see this is your A and this is your B dash. So I have to make the intersection of both A and B dash. Okay. So you can see A is y1, y2, y3, B dash is y1, y2, y3. So intersection is same y1, y2 and y3. So we'll be writing as y1, y2 and y. Then ninth one. So ninth one is A dash intersection B. So it's A dash intersection B. Now we'll be having both A dash also and B also. See, this is A dash P1 P2, B is P1 P2. So A dash intersection B is P1 P2. Then 10th, state the elementary events of the simple space for this experiment. Now what is elementary event? I told you that elementary events, that means event consisting of a single element. That means there should be only one element. Now they told you to make an elementary event from the sample space. So in sample space you can see there are total 5 elements. 1, 2. So if you want to make elementary event, there should be 5 elementary events, because in elementary events it should be only one element. So let us make E1, E2, E3, E4, E5. So E1 is Y1. Then E2. We are making elementary events E1, E2, E3, E4, E5. 5 events I'll be making. This was the first event. Now this is second event. This is third event. This is fourth event. And this is fifth event. These are the 5 elementary events. Then let's go to the 11th one. What is next? Can it be said that event A and B are mutually exclusive? Then give reasons. Now you have to say that if A and B are mutually exclusive or not. For that question, you should know what is mutually exclusive. Mutually exclusive is that there should be no intersection between A and B. You can see here, is there any intersection between A and B? A intersection B is null set. So my answer is yes. My answer is yes. Event A and event B are mutually exclusive events as A intersection B is equal to, as A event B is null set. A intersection B is null set, they both are mutually exclusive events. Yes. Can it be said that event A and B are exhaustive event? Give reasons. Now, what was the exhaustive event? Exhaustive event, that means A union B is equal to U. So, what is A union B here? Obviously, A union B is Y1, Y2, Y3, B1, B2. It matches with U, matches with sample space. Yes, yes. So, answer is yes. Event A and event B are called exhaustive event as A union B matches with U. As A union B matches with U. So we have completed illustration number 6. Yes. Illustration number 7. Let us write the question. A is 1, 2, 3, 4. B is minus 1, 0, 1. If sample space U is equal to A union B, okay, then find B dash A dash intersection B A minus B. In question, it is mentioned that if sample space U is equal to A union B. So let us write U. He told U is the sample space. Okay. So it should be minus 1, 0, 1, 2, 3, and it should be minus 1, 0, 1, 2, 3, and 4. Then let us find the first question. It is B dash. Now what is B dash? B dash, that means you have to look into the sample space, you have to look for the B. Elements other than event B are B dash. Okay. So B is minus 1, 0, 1. Look into the U, minus 1, 0, 1. What are the elements other than minus 1, 0, 1? It's 2, 3, 4. So your first question is solved. It's 2, 3, and 4. Now the second one. What is the second question? It's A dash intersection B. Now if I tell you to find this question A dash intersection B, then till what I taught you till now, you will be finding A dash. Okay. What is A dash other than A? Okay, so A is 1 2 3 4, so A dash should be minus 1 and 0. Then B. Okay, if what is asked, A dash intersection B, so A dash is minus 1 and 0. What is B? B is given in the question, you can see uh, in the question minus 1 0 and 1. So your answer will be A dash intersection B. So you can see here on the right side, minus 1 and 0 is your intersection. Minus 1 and 0 is your intersection. Now I'll do the same thing in another way. Now what is this another way? E dash intersection B is equal to, now actually this have a formula. What is A intersection B? A dash intersection B. A dash, that means A is not there, only B is there. So this is actually B minus A. Now you have to learn this formula. A dash intersection B is B minus A. Somewhere in the chapter it might be used, so I am teaching you here itself. Okay, A dash intersection B. A dash, that means A is not there. If A is not there, only B is there. Only B means B minus A. Okay. So B minus A is B minus intersection. B minus A is B minus intersection. So what is B now? Now you know what is B. It's minus 1, 0, 1. And you have to subtract intersection from that. And you also know what is intersection. You can see 1 is the intersection. Okay. So this will be, you have to subtract that 1 from this. So your answer will be minus 1 and 0. You can find with either method. Either you can use that above method also, and you can use this also. I have taught you both for the clarification of this topic. So A dash intersection B is B minus A. B minus A is B minus A intersection B. Minus 1, 0, 1 and minus 1. So we have done illustration 6 and 7. Let's continue further. Now I'll be doing number 666. It's exercise 1.1, number 6. Up till 5 we have done. The sample space of random experiment of selecting number u is 1, 2, 3, 4, 20. U is 1, 2, 3, 4. Now what is asked? Write the set showing the following events. The selected number is odd number. They're asking about that selected number is odd number. Let event A be the odd number. So you have to take odd number from the above series. So it's 1, 3, 5, 7, 9. It's 11, 13, 15, 17, then 19. Okay, it's 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. The selected number is odd number. Then second one. Selected number is divisible by 3. So your selected number is divisible by 3. D is equal to, so the number should be divisible by 3. So you have to write the table of 3. It's 3, 6, 9, 12, 15, 18. 6, 9, 12, 15, and 18. Third one. Selected number is divisible by 2 or 3. Selected number is divisible by 2 or 3. That means the number should be divisible by either 2 either 3. So you have to consider both the numbers. You have to consider the number divisible by 2 also. You have to consider the numbers divisible by 3. Now this particular thing I will be solving in a different way. How I will be solving? Let's pay attention here. Here it is asked the selected number is divisible by 2 or 3. So I'll make 2 separate and 3 separate. Let event A be, let event A be the multiple, let event A be the multiple of 2. A is 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So this is multiple of 2. Now let event B be the multiple of 3. Let event B be the multiple of 3. So it's 3, 6, 9, 12, 15, 18. That's it. Now you want divisible by 2 or 3. Now what is this 2 or 3? If you see 2 or 3, that means A union B is asked. How, sir? So keep a thing in mind. If it is asked like event A or event B occurs, okay, you can check if you have written on the events, union events. So you can check here if event A or event B occurs, that means it is A union B. Okay, I have taught you some things and I told you that I'll teach you in the later portion. So event A or event B occurs. So A union B, that means event A or event B occurs. So if it is asked that selected number is divisible by 2 or 3, you have to make the union. Now union is easy. You can see event A on the screen, event B on the screen. Just you have to mix it up. How will mix it up? It's 2, 3, 4. Just a second. It's 2, 3, 4. Then 6, then 8, 9, 10, 12, 14, 15, 16, 18, and 20. So you have to mix all the particular events. Yes. So that's it for today. We'll be continuing next in the next lecture. Thank you.